Preparing for a Kafka Developer interview? You've reached Candy Mentor. And this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Can you explain Kafka's core architecture and how data flows from producer to consumer? Kafka is a distributed commit log built around topics, partitions, brokers, producers, and consumers. Producers append records to topic partitions. Brokers store them durably and replicate them. Consumers read sequentially and track their own offsets, which decouples production from consumption. Zookeeper or Craft manages metadata depending on version. The key idea is immutable ordered logs per partition, giving high throughput, replayability, and scalable fanout without tightly coupling services. While answering, focus on brokers, topics, partitions, producers, consumers, offsets, replication, and the log-based storage model. Explain how Kafka decouples services and supports scalable event streaming. Question 2. How do Kafka partitions affect scalability and message ordering? Partitions are Kafka's unit of parallelism. A topic with multiple partitions can be written to and read from concurrently, so throughput scales across brokers and consumers. Ordering is guaranteed only within a single partition, not across the whole topic. If I need all events for one customer in order, I use customer ID as the key, so they land in the same partition. More partitions improve parallelism, but they also increase metadata, file handles, and rebalance cost. Make sure to cover partition-level ordering, key-based routing, parallelism, consumer group assignment, and the trade-off between more partitions, operational overhead, and ordering guarantees. Question 3. What is a Kafka consumer group, and how does it enable parallel processing? A consumer group is a set of consumers sharing the same grouped ID to process a topic cooperatively. Kafka assigns each partition to only one consumer in that group, so messages are not processed twice by group members. If I add consumers, Kafka redistributes partitions and increases parallelism until the number of consumers exceeds partitions. Different consumer groups can read the same topic independently, which is useful for fan-out use cases like analytics, billing, and notifications. In your answer, talk about group IDs, partition ownership, load balancing, one consumer per partition within a group, fan-out across groups, and how rebalances redistribute partitions. Question 4. How are offsets managed in Kafka, and when would you commit offsets manually? Offsets represent a consumer's position in each partition. Kafka stores committed offsets in an internal topic, usually consumer offsets. Auto-commit is convenient, but it can acknowledge messages before processing finishes, which risks data loss. I use manual commits when correctness matters. Read a batch, process it, write side effects successfully, then commit the latest offset. If processing fails before commit, Kafka can replay the records. That usually gives at least once delivery. So handlers should be idempotent. Be sure to mention committed offsets, auto-commit versus manual commit, at least once behavior, replay, external side effects, and committing only after processing succeeds. Question 5. Which producer configurations are most important for reliability and throughput? For reliability, I usually set AX equals all, retries to a safe value, and enable.idempotence equals true, so retried sends do not create duplicates. For throughput, I tune batch.size, linger.ms, and compression type, because batching and compression reduce network overhead. max.inflight.requests.per-connection matters for ordering during retries. The right settings depend on latency targets. A trading system may prefer low linger, while analytics ingestion can batch more aggressively for higher throughput. While answering, cover AX, retries, enable.idempotence, linger.ms, batch.size, compression.type, max.inflight requests per connection, key selection, and balancing latency against throughput. Question 6. What are Kafka's at most once, at least once, and exactly once delivery semantics? At most once means a message is processed 0 or 1 time. I commit before processing, so failures may lose data. At least once means messages are never lost if Kafka is healthy, but duplicates can happen because I commit after processing. Exactly once in Kafka combines idempotent producers, transactions, and transactional consumers for read process write pipelines. It does not magically make external databases exactly once, unless those writes are coordinated or idempotent. In practice, at least once plus idempotent business logic is common. Make sure to explain the practical meaning of each semantic: producer acknowledgements, consumer offset timing, duplicate handling, transactions, and why exactly once has scope limitations. Question 7. How do idempotent producers and Kafka transactions work? An idempotent producer prevents duplicate records caused by retries. Kafka assigns a producer ID and sequence numbers, and brokers reject duplicate sequence numbers per partition. Transactions extend this by allowing atomic writes to multiple partitions and offset commits in one transaction. In a Kafka Streams or custom read process write app, I can consume records, produce derived events, and commit offsets transactionally. Consumers using read committed only see committed transaction results, which avoids partial output. In your answer, include producer IDs, sequence numbers, duplicate prevention, transactional.id, atomic writes across partitions, read process write workflows, and transaction boundaries. Question 8. What happens when a Kafka broker fails, and how does replication maintain availability? Be sure to discuss partition leaders, followers, replication factor, ISR, leader election, min.insync.replicas, unclean leader election, and the availability versus durability trade-off. Question 9. What is the difference between Kafka retention and log compaction? Retention controls how long Kafka keeps records, usually by time or log size. After the retention limit, old segments are deleted, even if consumers have not read them. Log compaction is different. Kafka keeps the latest value for each key and can remove older values for that key. It is ideal for changelog or state topics, such as user profiles. A null value acts as a tombstone, eventually deleting the key from the compacted log. While answering, compare time or size-based retention with key-based compaction. Explain use cases, tombstone records, replay behavior, and state reconstruction from compacted topics. Question 10. How would you troubleshoot high consumer lag in a Kafka application? I start by confirming lag per partition, not just topic-level totals, using metrics or Kafka consumer groups. Then I check whether consumers are alive, stuck in rebalances, or blocked by slow downstream calls. If processing is CPU-bound, I scale consumers up to the partition count or optimize the handler. If Kafka is the bottleneck, I inspect broker disk, network, fetch sizes, and throttling. Lag is a symptom, so I separate application slowness from broker-side saturation. Make sure to cover measuring lag, checking consumer throughput, partition count, slow processing, rebalances, broker health, GC, downstream dependencies, and scaling or tuning options. Question 11. How do you handle schema evolution in Kafka event-driven systems? Schema evolution is about changing event formats without breaking existing producers or consumers. I prefer Avro or Protobuf with a schema registry rather than unstructured JSON. Producers register schemas, and compatibility rules prevent unsafe changes. Backward compatible changes, like adding a field with a default, let new consumers read old messages. Forward compatibility helps old consumers ignore new fields. The best practice is to treat events as contracts and evolve them carefully. In your answer, talk about Avro, Protobuf, JSON schema, schema registry, compatibility modes, versioning, backward and forward compatibility, and avoiding breaking consumers. Question 12. What causes Kafka consumer rebalancing, and how can you reduce its impact? A rebalance happens when consumers join or leave a group, partitions are added, or Kafka thinks a consumer has failed. During traditional eager rebalancing, consumers may stop processing while partitions are reassigned, which can increase lag. I reduce impact by tuning session.timeout.ms, heartbeat.interval.ms, and max.poll.interval.ms, avoiding long blocking processing in the poll loop, and using cooperative rebalancing where possible. Static membership also helps stable deployments because restarting a consumer does not always trigger full reassignment. Be sure to mention group membership changes, partition changes, session timeout, max poll interval.ms, eager versus cooperative rebalancing, static membership, and processing pause during reassignment. Question 13. Design a Kafka-based pipeline for processing millions of user activity events per minute. I would create a user activity topic partitioned by user ID or session ID, depending on ordering needs. Producers would use batching, compression, idempotence, and schemas registered centrally. Consumers would run as a scalable group, with one processing path for real-time enrichment and another for analytics storage. Invalid events go to a dead letter topic with error metadata. I would monitor producer errors, broker throughput, consumer lag, and downstream latency. Retention should support replay during incidents. While answering, describe topic design, partitioning key, producer batching, consumer group scaling, schema management, dead letter topics, monitoring, retention, and downstream storage choices. Question 14. When would you use Kafka Streams instead of writing a plain consumer application? I use a plain consumer when the logic is simple, such as reading events and writing them to a database. Kafka Streams is better when I need stream transformations, aggregations, joins, windowing, or local state stores. It manages partition assignment, state recovery, changelog topics, and processing topology for me. For example, counting purchases per user in 5-minute windows is much cleaner in Streams. The trade-off is less low-level control and a stronger Kafka-centric processing model. Make sure to compare low-level consumer control with Kafka Streams abstractions, stateful processing, joins, windows, state stores, exactly once support, and operational simplicity. Question 15. How would you secure a Kafka cluster and its client applications? I secure Kafka in layers. First, I enable TLS for encryption in transit between clients and brokers. Then I use authentication, such as SASL, SCRAM, MTLS, or Kerberos, depending on the environment. Authorization should use ACLs, so producers and consumers only access required topics and groups. Secrets must come from a vault or managed secret store, not config files. I also isolate brokers at the network level, monitor audit logs, and rotate credentials regularly. In your answer, include authentication, authorization, encryption, ACLs, SASL, SSL or TLS, secret management, network isolation, audit logging, and principle of least privilege. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.